Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Josh Beigman, and along with Henry Stanton, we are your hosts for episode 24, called The Chemistry of a Crocodile's Stomach. Today we're going to discuss the chemistry of the most powerful digestive system in the animal kingdom.
So crocodiles are large carnivorous reptiles who will prey on basically anything that they can swallow whole, which means that in order to digest all of these animals that they're eating, they need very strong digestive systems and stomachs. So they have developed through evolution very unique ways to increase the digestive abilities of their stomachs, and now have the strongest stomachs in the animal kingdom.
Yeah, so the reason they need these strong stomachs is they're not able to actually chew or choose what they eat because their jaws are so huge. So they swallow everything, and that includes bone and cartilage in addition to all the meat. And that's pretty important. I mean, they're not the only animal that swallows things whole. I mean, we know snakes do that too. But snakes will take several weeks to digest whatever they ate. And the crocodiles finish that off in a couple days.
Yeah, they're able to do it a lot faster.
It's supercharged.
Yeah. Crocodile stomachs are actually so strong that they are able to dissolve steel nails in their stomachs, which is very impressive.
You ever wonder who decided to test that? Let's just feed a croc a steel nail. That's a good idea.
I cannot imagine doing that.
Seems pretty foolish. But also kind of interesting. You wonder what else they could have stuck in there.
It's important for us to understand how stomachs work in general before we talk about what makes crocodile stomachs so much more powerful than, say, a human's stomach. And the hydrochloric acid is what makes any stomach able to break down the foods that come into it. And this is because the hydrochloric acid is a strong acid that dissociates into positive hydrogen ions and negative chlorine ions, which denature the proteins.
Protein is a bunch of amino acids that are held together by hydrogen bonds. Mm-hmm. And when you have a really acidic environment like hydrogen chloride, which is completely dissolved in water, the ions, the negative Cl- ions and the H+ ions are more powerful, cause more powerful ion dipole bonds with the negative oxygen and the positive hydrogen that's in the amino acids. So it breaks down the whole structure, and we're left with just the amino acids that are then can be processed by other enzymes in the stomach.
Yeah, okay.
So basically, the more hydrogen and chloride ions present, the faster the structure will break down, and the faster the food will get digested. So the way animals produce hydrochloric acid in order to break down the food, as Stan just explained, is that they have carbon dioxide in the bloodstream, and it mixes with water to create carbonic acid. And that immediately dissociates into H+ ions and HCO3- ions. And through these biological mechanisms, like an anion exchanger, basically the HCO3 goes in to this exchanger, and then Cl minuses released into the stomach. And the same thing happens with the H plus. And then the H plus and Cl minus ions end up in the stomach and they create hydrochloric acid. So the more carbonic acid an animal is able to produce, the more hydrochloric acid they will end up in the stomach. So the crocodiles have a way of maximizing this. Normal animals have a certain level of CO2 in their bloodstream, and the crocodiles have a way to make that level a lot higher than in other animals.
Yeah, the crocodiles have an extra valve in their heart that diverts carbon dioxide-rich blood. Instead of going to the lungs where it would lose all the carbon dioxide, it goes to the stomach to help create more carbonic acid. And when there's more carbon dioxide, more carbonic acid can be produced, and then more H plus ions, and therefore hydrochloric acid can be produced, and then you have a stronger stomach in the crocodiles. And yeah, that's basically the secret to crocodiles having the stronger stomachs, is they're able to produce more acid because of the larger amounts of carbon dioxide in their bloodstream.
Yeah, they actually produce 10 times as much hydrochloric acid in their stomachs as we do, which is a ton of hydrochloric acid, because we already have 2 liters of it created every day.
Yeah.
So they're just dumping hydrochloric acid into their stomachs.
So let's talk about why we wanted to discuss this topic today. We always knew that stomach acid was a very powerful substance and could dissolve everything that we ate, but we also knew that human stomachs weren't able to digest a lot of foods that other animals eat, such as rotten foods.
Think about it. Do you ever think like it's kind of unfair that we have like 2-day-old milk or week-old milk, and our stomachs go, we have a whole
We just can't
problem.
handle it.
You start having a lot of issues, and then you have like freaking vultures eating 2-week-old carcasses, and it's actual food for them. So how if you were gonna engineer a stronger stomach for yourself, how would you do that?
I think you gotta go with how the crocodiles do it and get more carbon dioxide in your blood going to your stomach. And I'm not sure how one would do that. Maybe the extra heart valve that the crocodiles have, maybe.
Well, I don't think we can grow an extra heart valve, but maybe we can inject take a carbon dioxide pill or something. Thank you to Wikipedia. Go donate before they go under. Just $5 from each person will keep them running for years to come.
All right, well, thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.